Hello everyone, myself Sakshi Mittal. I'm assistant professor in Department of Electronics and Communication Engineering, Ajay Kumar Garg Engineering College, Ghaziabad. I welcome you all to my complex lecture series on 8251 USART topic for subject Microprocessor KCS 403. So in this lecture, I'm going to discuss about 8251. It's addressing what is its architecture, its pin diagram, what are the different modes in which 8251 works. So we'll start. First, the data communication. What is USART? USART is actually a universal synchronous asynchronous receiver transmitter. So for what purpose USART is being used? It is being used for communication. So what is data communication? So data communication refers to the ability of one computer to exchange information with the another computer or any peripheral. So if you want to exchange information between two peripherals, between two devices, that you want to have a device-to-device communication, then you need some standard data communication interfaces, or some standards are needed. So generally, the RS-232, it defines the serial communication standard. So RS-232 is the serial communication standard which is generally used for communication from one computer to the another. 8251 USART, that is Universal Asynchronous Synchronous Receiver Transmitter. It is the component for converting your parallel data to serial form and serial to parallel, that is vice versa. So we can have two types of serial data communication, asynchronous and synchronous communication, and USART supports both the types. So first, as we discuss about the synchronous and asynchronous, when we talk about synchronous and asynchronous, we said in asynchronous, the transmitter and receiver, they are not synchronized. So if they are not synchronized, that means they both of them are operating at their own clock. So they are not synchronized. In case of a synchronous communication, transmitter and receiver, they are synchronized at the same clock. So you do not need any information, you do not need any extra information to be transmitted in case of a synchronous transmission, because both the transmitter and receiver, they're at the same clock, so both of them will join at the same time. And in case of asynchronous, somebody is receiving at some other time, the other one is receiving the data at some other time. So you need some extra bits to let them know when you have transmitted the information. And like the message you used to transmit, if I talk about the message, then I have transmitted the message at some time, and the receiver can read it at any time at which they are free. If I talk about the phone call, then in case of a phone call, the time at which I am communicating, at the same time the receiver is also communicating with me. Next, we talk about the transmission. It is the simplex, half duplex or full duplex. So you have got a sender and a receiver, and if the information is one direction, that means if the information can be transmitted only from a sender to the receiver, we call it as a simplex transmission. In case of a half duplex, either the sender can send the data or receiver can send the data, but only one at a time. So if I talk about if I take an example of a computer and or a printer, or you say the broadcast, like the TV transmission. So the signals, you are just receiving the signals, you cannot upload anything. You can just downlink the signals. The same way, if I talk about the half duplex, then half duplex is that you can either transmit or you can receive. But you can do both the things, but only one at a time. So like the walkie-talkies. In case of walkie-talkies, a good example of half duplex. It's a both way. It is a two-way communication, but only it supports one-way communication at a time. Then the full duplex. Full duplex says that you can either transmit the data or you can receive the data. Both are simultaneously. So it is a bidirectional path. So both paths are provided like a phone call. So you can talk as well as you can receive the information. So full duplex, you say that the transmission and reception can occur simultaneously. Now this about 8251. This is a programmable communication interface. This is USART. So it is universal, synchronous, asynchronous, receiver and transmitter. So it is an IC which is with the number 8251, which is being used for synchronous as well as asynchronous transmission, and can be used for reception as well as transmission for serial data communication. So the programmable peripheral has been designed for synchronous as well as asynchronous communication. It is packaged in a 28-pin dual inline package. It receives the parallel data from CPU and transmits the serial data after conversion. So it will get the parallel data, it will transmit, it will convert it into the serial data, and then will transmit it after further conversion. Same way, it also receives the serial data from outside and will transmit the parallel data to CPU after conversion. So it supports parallel to serial and serial to parallel conversion. This is a 28-pin diagram for 8251 IC. So first is about the data bus. It has got the 8-bit data bus, D0 to D7. These 8 lines actually, D0, D1, D2, D3, 4, 5, 6, 7. These are the 8 data lines which are being used to interface this peripheral with the processor. So if you want to connect it with 8085, 8085 is an 8-bit processor. It has also got an 8-bit data bus. So that data bus is directly connected with the data bus of this 8251. So that the information, all the data can flow between those devices. As 8085 doesn't have any other pin for connecting the peripherals. So all the peripherals are connected to processor via data bus. Next is RxD, it is receive data. Then GND is the ground reference. TXC transmitter clock. WR write bar signal. CS chip select signal. C/D that is command or data. RD bar read bar. RX ready receiver ready. Then TX ready, that is a transmitter ready. Next on 16th pin we are having sync detection or blank display. Then CTS clear to send. Transmitter empty. TXD transmit the data. Clock reset. DSR data set ready. RTS request to send. Then DTR data terminal ready. Now RXC receiver clock. Then VCC plus 5 volt power supply. So this is the block diagram of 8251 USART. So the block diagram is basically, first it is interfaced with the data bus buffer. So the data bus buffer, it is having 8 data lines which are being connected with the processor's data bus. 8085 data bus is being connected with the data bus buffer of this peripheral. Then you have got a read-write control logic. On this read-write control logic, you have certain pins which will enable the read and write operation. And to enable this 8251, we have got a chip select signal. So if chip select signal is active low signal, if it is 0, then this will complete chip, the 8251, it will be active, otherwise it will be disabled. Next is COD, that is command or data. The information which you are transmitting, is it a command or a data? If it is something maybe it is have some synchronizing bits, it has certain information which is only for control purpose, but it is not an information for you. So the command and data are two separate things. So if this pin is 0, that means you are sending data. If it is 1, it is a command. Then clock. So it is a clock signal at which it will operate. Generally, the processors like 8085 is having a clock out pin. So clock out is nothing but it is a clock signal for the devices connected with the processor. So clock out is generally connected with this clock pin. Same way the processor, if I talk about 8085 has got input output read bar and input output write bar. These pins are being connected to your read and write control signals. Next is a modem control. Modem control, actually it has got the 4 specially designed signals for data set ready, data terminal ready, request to send, clear to send, which defines the complete process. Apart from this, it has got a transmitter and a receiver section. The transmit and receive section has got a control block along with a buffer. So control block, it has got a transmit, it has a pin transmitter ready, which will indicate whether the transmitter is ready or not, whether the transmitter is full or it is empty. It has got an input which defines the clock for transmitter, and the transmit buffer. So transmit buffer is nothing but will perform the function for the parallel to serial conversion, and after conversion it will transmit the data via your TXD pin. So the data will be available on TXD pin. Same way the receive buffer, it will receive data from this RxD pin, receive data. After receiving the data, it will convert it into parallel form. You have got a serial data, you will convert it into parallel form, and after that, once it has been converted into the parallel form, then the data in parallel form can go to the data bus, because data bus is nothing but it is a combination of your 8 parallel wires. You have got a receive control block, which is receiver ready, receiver clock, and sync detection. The synchronizing bit there can be detected. Now we will discuss each component in detail. So the architecture of the sections of 8251, they were divided into data bus buffer, read-write control logic, modem control, transmitter, and the receiver part. First, talking about the data bus buffer. So 8-bit data bus, it is used to read or write status, command, word, or the data to or from 8251. Next is the read-write control logic. So it includes a control logic, 6 input signals, and 3 buffer registers. That is your data register, control register, and status register. So got 3 registers: a data register, control register, and status registers. Now the control logic, it interfaces the chip with microprocessor unit, determines the functions of chip according to the control word in the control register, and monitors the data flow. So the control logic is used to monitor where the data is actually going, and it is used to function as per the command word you have sent. Then the input signals. First is the chip select. So chip select is nothing but is active low signal, which is used to activate the 8251. Then C/D, that is control or data, whether you are transmitting a command or a control signal or a status signal, or you are transmitting the data. Then write bar. So write bar is again an active low signal, which says that the microprocessor either writes in the control register, or you can just send the output to the data buffer. So it is used for write purpose. Same way, the read bar is again an active low signal, which will read data or status from the registers or the data buffer. Then reset. We have got a reset signal. Yes, the reset of 8251 is connected with reset out of 8085, because 8085 has got a signal reset out which says that it can reset the devices connected with the processor. So the reset of 8251, it is connected with 8085's reset out, and a high on this signal, it resets the 8251 and it forces it to be in idle mode. Then clock is a clock input, usually connected to the system clock, or to be in communication with the processor. As I already told you that the clock is generally connected with the clock out pin of 8085. Then the control register. So a 16-bit register for a control word consists of 2 independent bytes, namely mode word and a command word. So 16-bit register, it is divided into 2 parts, a 8-bit mode word and a 8-bit command word. The 8-bit mode word specifies the general characteristics of operation, such as at which baud rate you are going to operate, what is the parity, the number of bits being used. Command word enables the data transmission or the reception. So register can be accessed as an output port when the control or data pin is high. Next is the status register. So it checks the ready status of the peripheral. Status register will always tell your status, whether you are ready or not. So status word in the status register provides the information concerning register status and its transmission errors, where if it has got any error in its data. It can have a parity error, it can have a overrun error, it can have a framing error. So the status registers, its role is to provide your information related to that particular register and if any error has occurred. So the data register, it can be used as an input and output port when C/D, that is your command or data, is low. So just see in this table, the chip select, it is 0. If it is 1, if chip select is 1, that means 8251 is not being enabled. So chip is not selected for any operation. So if you want to operate in 8251, you need that chip select should be 0. So chip select bar is 0. Now C/D bar, so command or data. Whenever you are having it as 0, that means C/D bar. So you are having it as a data, and if it is 1, that means it is something information related to a control or status. Now how will you get whether it is a control information or it is some status of something? So always remembers, you always reads the status and you write the command word or the control information. And data, you can either read data from data buffer or you can write data from data buffer. So all these combinations, they define what kind of operation you are doing. Then is the modem control. So modem control is having the 4 information like the modem control. First one is the data set ready. It checks if the data set is ready when communicating with the modem. Data terminal ready. Data terminal actually it indicates to the end device, end components whenever they are ready. So data terminal indicate that the device is ready to accept data when 8251 is communicating with the modem. What actually happens is, suppose you have got a end component. If you want to transmit something, first thing is you will turn off the power. It will say I am ready. So whenever that end device is ready, it says I am ready with the help of DTR, data terminal ready. Then it will check the next device. So you have sent the data to the modem. Then modem is ready. If modem is ready, then you say that DSR, data set ready. It is ready. Now, if the modem will check the path on which it has to transmit the information to the receiver. While checking the path, first it will check the path. If the path is clear, it will send the signal clear to send back to the end terminal, that is their computer, and it says that the path is clear, so you can transmit the information. So if it is clear, if it is low, then 8251 is enabled to transmit the serial data provided by the enable bit in the command bit. Byte is set to 1. So clear to send indicates that the path is clear, you can transmit the information. This information is being transmitted from modem to the end device, that is your computer. Then request to send. Now end terminal has got the information, the path is clear and you can send the data. So now the computer will request modem that please send the data. So it will assert signal request to send. So low on this signal indicates that the receiver is ready to receive a data byte from the modem. That means modem is actually sending something. So we have got an end device, maybe here a computer. You have got a computer. End device is again here a computer. When transmitting a information, in between you need a modem. Here also you have got a modem. So first you will just turn on the power. You have turned on the power, it says data terminal is ready. Then it checks whether this modem is ready. If modem is ready, modem will reply that yes, data set ready. I am ready to send or receive something. Then it says okay. Then modem will check for the path. If the communication path is available, if the receiver is available, if it finds everything is perfect with it, then it will send again a signal to the DTR, clear to send, that the path is clear, you can send the information. If everything is perfect, then this DTR, it will assert another signal. It will assert another signal which is RTS, request to send, please send the data. So the RTS indicate that the modem is actually transmitting the data. Next is the transmitter section. So transmitter section accepts parallel data from microprocessor unit, converts it to the serial data. It has got 2 registers, a buffer register and an output register. Buffer register is nothing but the storage. It holds the 8 bits. Output register convert the 8 bits into a stream of serial bits. It writes a byte in the buffer register. Whenever the output register is empty, the contents of the buffer register are transferred to the output register. It consists of 3 output and 1 input signal. TXZ is a transmitter data output. So the data will be transmitted through this pin. Transmitter clock, it is the input signal. Transmitter ready, it indicates whether transmitter register is ready or not. If USART is ready to accept the next data byte or not. Transmitter empty, that indicates that the register is empty and USART is ready to accept the data byte. Next is the receiver section. So it accepts the serial data on the receive pin and converts them to the parallel data. It has 2 registers, a receiver input register and a buffer register. Same way like the transmitter block has got. So when our receiver ready, when you received data, it goes low. The control logic assumes that it is the start bit and it waits for half bit time, samples the line again. If the line is still low, the input register accepts the following data, loads it into the buffer register at the rate determined by the clock receiver. Receiver ready, that means receiver is ready, is the output signal, indicates that it is ready. It is ready to transfer it to the data to the microprocessor unit. Then receive data. It is a pin at which you will actually receive the data. Then receiver clock that controls the rate at which bits are being received. So now we have got 3 registers. We will discuss about the 3 registers. First is the mode instruction format. It is a 8-bit register, where the first 2 bits indicates the baud rate selection. It says at the baud rate is nothing but the rate at which you transfer your bits. The bits transmitted per second. So it says either you can operate in synchronous mode or you can operate in asynchronous mode. So 0001, 1011, you can have 4 combinations. It says either you can operate in synchronous mode or you can have a baud rate which is a multiple of 1, multiple of 16 or multiple of 64. Next, D2 and D3 bits indicate the character length, the data which you are transmitting. What is the character length? So you can have up to 8-bit character length. That is, you can have a 5-bit data, 6-bit data, 7-bit or 8-bit data. Next is the parity. Whether you have enabled the parity or you have disabled it. If it is 0, you have disabled it. If it is 1, you have enabled the parity. Then odd or even, once you have enabled the parity, once this bit is 1, you have enabled the parity. Next you will say whether it is odd parity or even parity, whether it is 0 or 1. And last is the stop bit selection. Stop bit is nothing but like it is a termination symbol, like a full stop you used to use in your sentences. So you can have 1 stop bit, you can have 2 stop bit, you can have a 1.5 stop bit, or maybe you don't want to have a stop bit. So you, the stop bit actually when you are transmitting data in asynchronous mode, it is actually you first send the start bit, then you will transmit your data bits. After data bits, you always need to send a stop bits in case of asynchronous transmission. And if you say the combination is 0, 0, that means invalid. Then is the command instruction format. Now this is the command instruction. It enables the data transmission or reception. So first is TXEN, transmitter enable. If it is 1, transmitter is enabled. Otherwise you can disable it. Then DTR, data terminal ready. Whether data terminal is ready or not to send or receive data. If data terminal is ready, then only you can transmit something. Then RXE is receive enable. Whether receiver you can disable it with the, if it is 0, you can disable it. Then SBR is send break character, like you used to press the spacebar key, the break character. So you can just force it to send 0 as a break character. Then ER is the reset error flags. What all error flags you can have here? We can have a parity error, overrun error, or we can have a framing error. So this ER, if it is 1, it can reset the error flags. Next is RTS, that is request to send. If it is 1, then it is disabled and it forces RTS to 0. Next is IR, internal reset. So it is the internal reset for 8251. Last is EN, enable the hunt mode. So if it is 1, it will hunt for the synchronizing characters, because in asynchronous transmission you are transmitting a start bit, data bit and stop bit. But for synchronous transmission, you are sending some synchronizing bits along with your data for synchronizing purpose. Next is the status information. So the status, again a 8-bit information. First we will tell about the transmitter, whether the transmitter is ready or not. So this indicates the USART is ready to accept the data. Next is the receiver header, where receiver is ready. So if receiver is ready, it will be 1. Next is transmitter empty. So again the same as we have already seen, that the buffer, we indicate that the transmitter buffer is already empty. Then these 3 are the error: parity error, overrun error and the framing error. So if you have sent a odd parity, you have received the data from the even parity, then it will be 1. If there is overrun error, or overrun says that you have already transmitted, that the flag is set when CPU does not read a connector before the next one becomes available. Overrun, there is a speed mismatch. Then is the framing error. Framing error says when a valid stop bit is not being detected at the end of data. We call it as a framing error. So the complete frame is not being detected. Then is the sync detection. And last is the data set ready. It indicates that data set is the when the data set ready, it is ready or not, if it is 0 or not, or 1. So this was all about 8251, its architecture, block diagram, the registers which are being used, and these are the references which I have gone through for this lecture. And if you have got any doubt, then you can contact me. Thank you.